Today we're going to look at adding and subtracting algebraic fractions. An algebraic fraction is a fraction that contains an algebraic expression in the numerator or the denominator. Here we have some examples of algebraic fractions. This one has an algebraic fraction in the numerator, this one has one in the denominator, and this one has an algebraic expression in both the numerator and denominator. Algebraic fractions must have the same denominator before adding or subtracting them. This is exactly the same as any other normal fraction. So if we've got the fractions 2a over 3 and adding b on 5 to them, they need to have a common denominator before we can add them. So both of these have a common multiple of 15, so we can multiply this by the top and bottom by 5 and this the top and bottom by 3 to get 10a on 15 plus 3b over 15, and then we can add the top and leave it all over 15 then. First example, find the lowest common denominator of 3x on 10 and 2y on 15. So we're just looking at the denominators here. We want to find the lowest common denominator of 10 and 15, or lowest common multiple. So our multiples of 10, we can list them are 10, 20, 30, 40, 50, 60, and so on. And the multiples of 15 are 15, 30, 45, 60, etc. So the lowest common multiple that we've got here is 30. That's the lowest number that we've got that is common to both of them. So 30 is our lowest common denominator. For b, converting 2x over 7 to an equivalent fraction with a denominator of 21. So currently our denominator is 7, we want to get it to 21. So we can multiply by 3 to get from 7 to 21. So if we do that to the top and bottom, 2x times 3 is 6x and 7 times 3 is 21. So our equivalent fraction is 6x over 21. Second example, we've got 4 parts of this example. Our first question here, they've got the same denominator. So because these two algebraic fractions have the same denominator, we can just add the numerators and keep the denominator as 11. So adding the denominators, they are like terms, so they're both x, so 3x plus 5x is 8x all over 11. Here, for our second part, we do not have the same denominator, so we need to convert these fractions to an equivalent fraction for each of them with their lowest common multiple, our lowest common denominator. So these have a common multiple, 3 and 5 have a common multiple of 15, so we can multiply the top and the bottom by 5 here to get 15, and multiply the top and the bottom by 3 here to get 15 on the bottom. So here 4a times 5 over 15, and here 2a times 3 over 15, and then we'll have the same denominator. 4a times 5 is 20a over 15, and 2a times 3 is 6a over 15. Here then we can now add the numerators with our common denominator. 20a plus 6a is 26a. For part C, the question was, the example is 6k over 5 minus 3k over 10. We don't have a common denominator, we do not have the same denominator, but we can find a common denominator. 5 and 10, the lowest common multiple of 5 and 10 is 10, so we don't have to change this fraction, second fraction at all. We can multiply the top and the bottom here by 2 to get 10 on the bottom. So multiplying by 2 gets 12k over 10 minus 3k over 10. We haven't changed this one because we haven't changed the denominator. So 12k over 10 minus 3k over 10, we can put that over a common denominator. And 12k minus 3k, we're left with 9k because these two are like terms. They've got the same combination of variables. Last problem, a on 6 minus b on 9. We can get a common denominator of 18. The lowest common multiple of 6 and 9 is 18. So we can multiply the top and the bottom by 3 here, multiply the top and the bottom by 2 here. So here, a times 3 over 18 minus b times 2 over 18. So now we've got our common denominator. We've got 3a on 18 minus 2b on 18, just multiplying those two, and we're left with all over 18, 3a minus 2b all over 18. We can't add these two together because they are not like terms. A and b are not the same variable.